Okay, this video is for Algebra 2, Unit 3. It's our test study guide. So starting with topic 1, we have the introduction to parent functions. We know so far how to do linear, absolute value, and quadratic functions. The parent function for each is actually just like the most basic way that you could graph or describe each of these functions. For linear, remember the root word is line. Okay, we have a diagonal line that will be our function. And the parent function equation would be f of x is equal to just x. What this tells me, if we think of it in comparison to y equals mx plus b, that we are starting at the origin. It's like saying plus 0. And when we say x, remember the number in front of x is our slope. So that would be a slope of 1 over 1. So up 1, right 1. Okay, so it is a nice diagonal line with a slope of 1 over 1 that passes through the origin. And that's our parent function for our linear equation. Now, any translations would be added to that f of x. Then we learned at the beginning of this unit how to do absolute value functions. The most simple way we could describe this is as f of x is equal to the absolute value of just x. Now, after learning our vertex rules, this would tell us that the vertex of this function would be at 0, 0, and we do not have a number in front of our absolute value bars, so we have a slope of 1 over 1 as we move to the right, and then we mirror that as we work to the left. Absolute value functions always create a V shape that's symmetrical about the vertex, okay, and continues on in either direction forever. So that's our absolute value parent function. And last in this unit, we learned about quadratics. And ironically, quadratic does not mean 4. Quad doesn't mean 4 here. It means our x value is squared. So the parent function for this one would be f of x is equal to x squared. That's the most basic way I could describe it. This tells me that I have a vertex that is at the origin, 0, 0. And if I plugged in 1 or negative 1, out would come positive 1, so it's going up by 1 on either side. But if I plugged in 2, out would come 4. The same with negative 2. Negative 2 times negative 2 is also 4. So we don't get a V shape here, we get a rounded U curve with a vertex resting on the origin. So our transformation rules in topic 2, they describe in the equation how we are moving our function across the coordinate system. Like, are we shifting it up or down, left or right? Are we stretching it, making it skinnier? Or are we shrinking it and making it like fatter? Okay, so, or reflecting it. Those are all of the different types of transformations that we have learned so far. And these rules apply to absolute value functions and quadratics in pretty much the same way. So remember, we have what is called here on the side f of x plus h in parentheses. So we talked about if anything is either inside the absolute value bars or inside the parentheses with x, because the x-axis moves left to right, we are either going to have a left or right transformation. But our x's are silly. They always do the opposite thing. So if we have a plus sign inside the bars or the parentheses, we are being expected to shift or translate our function or our vertex left, what we call h spaces. Whatever number is inside with the x, plus means left. So x's do opposite. Now moving to the right here, we have f of x minus h. Again, because it's inside the bars or parentheses with the x value, it has to be left or right. But minus means to shift our function or our vertex to the right. So we would say right h spaces. Okay, moving on, we have f of x plus k. What does that mean? Well, our vertical shifts happen after our absolute value bars or after our x squared set. So, and then we call that the k value. So the k value, the y vertical shift, it is pretty straightforward. We don't change our signs. They do exactly what that number says. So if we have plus k, that means we go up that many spaces or up k spaces. If we have subtracted an amount after our absolute value bars or after our parentheses, we are supposed to shift down that many units, or we would say down k units. Okay, now our vertical stretches and shrinks. If we have a number, we call that number a here because it represents any different number that it could be, on the outside of our parentheses or on the outside of our absolute value bars. And by outside, I mean in the front. It almost would look like you were supposed to distribute it in, but we don't. Okay, if the absolute value of that number, so we're just looking at the number portion, is greater than 1, we have a vertical stretch. Okay, it's getting, our arms or the bars are really close together, so it looks a lot skinnier. Okay, it's been stretched vertically, pulled together. Now, if that A value that's out in front of the bars or in front of the parentheses has an absolute value that is less than 1, so like 1/2 or 1/3, a fraction less than 1, then we are going to have a vertical compression or a vertical shrink, we sometimes call it. Okay, shrink and compression mean the same thing, but it's being squeezed bottom to top, squished down, and it makes the arms like flatten out. So we would almost say like it's fatter, and a lot of times I say fractions make it fatter, but only fractions that are less than 1. Okay, and then we have our last piece here. We have a negative and then f of x, and what that's referring to is that we have a negative like in front of our A value or in front of our bars or in front of our parentheses, and what that means is our arrows are headed downwards now. We call that a reflection across the x-axis. Okay, so a lot of times, if it was a parabola, I would say that was a sad parabola or sad V because it was negative. And negative people, they're just down. They're downers. So across the x-axis. So those are our transformation rules, and we will apply them to the next set of problems to help us find the vertex and graph our functions. Okay, for topic 3, we are graphing from vertex form absolute value functions. Okay, so we always start by finding the vertex. We've gone over our transformation rule. So again, starting with the vertex, which I'll label as V. The vertex is a coordinate, an x value and a y value. The x value of the vertex is always a number that's inside the bars with the x, but we take the opposite sign. So I had -2 inside, it comes out as +2. That's the rule. The y value is the number that's being added or subtracted after that. That's -7, and we don't change the sign. So our vertex is at +2 for x, -7 for y. So we are down right here. We plant our first dot. And then we want to check what's our slope. The slope would be located out in front of the bars, like out here is where I'm looking. Notice there is no number there. What that means is that there really is a coefficient of 1. So our slope is 1/1. Up 1, right 1 as we work to the right of our vertex. But all absolute value graphs make a V shape. So don't forget to come back to your vertex and work up 1, left 1. So we get a nice symmetrical V shape. Okay, so there we go. Now we got to answer our questions. What was that vertex again? That was 2, -7. That's the center of our graph. What's the domain? We have left to right spread. Okay, we're spreading from left to right forever without any interruption. So our domain is all real numbers. Our range, we're looking for a highest or a lowest point. Basically, we're looking where our vertex at. And what is that y value? The y value is -7, and then our arrows, or the graph in other words, is always moving above that. So we have our y values that start at -7 and are always moving above that. So that's why we would say our range is all the y's such that y is greater than or equal to -7. Greater than is always meaning to go above. Okay, number 2, we have f of x equals -2 times the absolute value of x plus 4. So again, starting by identifying the vertex. Okay, what is the x and y shift that we have here? Notice that this x is all by itself inside the absolute value bars. We're adding nothing or subtracting nothing from that. So that means our x value is staying at 0. We have a +4 here on the outside of the bars, so that is our vertical shift of going up 4. So there we have our vertex of 0, 4. We'll label that, and we will stay at the origin, but then go up 1, 2, 3, 4 spaces. Okay, what is our slope? That's the next piece that we need to identify. We have this -2 out in front of the bars. Okay, that number out in front always represents a slope. I like to think of it as a fraction, always -2/1 if it's not already a fraction, which means we are going down to right 1 of the vertex. So down to right 1. Okay, notice because that absolute value of 2 made it a little bit skinnier than usual. We go back to our vertex because we need to make this a V, and we're going down to left 1. Always mirror to make it symmetrical. We connect our points. Okay, now the domain of every absolute value function is all real numbers. Okay, we have left to right movement without interruption always. What is the range? At this point, we're looking for our highest point. That's again going to be at the vertex because the vertex is the turning point, and that value is 4. And again, you should recognize that it's the same y value from the vertex we already identified, 4. We start having y values at 4, and we're everything below 4 for y. So we are going to write this as all the y's such that y is less than or equal to positive 4. So for numbers 3 and 4, we are working backwards. We're going to be told the transformations that are happening to the absolute value function, and then we're going to write the equation that represents that. So on number 3, it says we are reflected about the x-axis and then shifted 5 units left. Okay, so we always start with f of x equals. I know that I'm going to have absolute value bars, okay, and an x inside to begin with. What are we adding to that? If we are reflected about the x-axis, that means that we have to put a negative sign at the very front of that, to the left of the bars. Okay, so this right here is our reflection, and then we are shifted 5 units left. When I see left, that actually means to add inside with the x value inside the bars. And we put plus 5, because when that plus 5 comes out of the bars, it would be the opposite sign, negative 5, which again, left of the origin would be negative. So this right here is the equation that represents what number 3 is talking about. Okay, number 4, we have a vertically compressed by a factor of 1/3. Okay, so I know that I'm going to have a 1/3 out in front of my bars, so I can start building my bar next. Then shifted 1 unit up and 2 units right. Well, I like to work left to right, so let's talk about this moving right. I'm going to have inside the bars x moving right. Again, means that we would subtract. It's the opposite of what we think it should be. Right 2 units is x minus 2 in the bars. And 1 unit up happens after we close those bars, and its signs stay the same. So we're going to say plus 1. I'm going to throw an f of x equals in front of that. So we have our 1/3 compression. This minus 2 means we moved right 2, and the outside plus 1 means we moved up 1. Okay, on numbers 5 and 6, we have absolute value inequalities. That means we've just added this greater than or less than sign after our y. It really doesn't change anything when it comes to finding your vertex or plotting your points. It just changes maybe how we connect our points, and we will always have shading either above or below the line. So we still are going to start in the same way. We're going to identify the vertex. So again, what's that xy value for the center of our V that we're going to create? And again, I know it's a V because it has absolute value bars. So the x value of the vertex, if I have plus 6 inside with the x, it comes out as negative 6, always the opposite. The y value of the vertex is what comes after that. It's negative 4. Its sign stays the same. So we're at 6 left and 1, 2, 3, 4 down from the origin. I still need to use the slope to help generate some points here. What's the number out to the left of the bars or just in front of them? There isn't a number there, but I know that means 1/1. Up 1, right 1 of the vertex. Okay, and then I mirror that on the left for as many spaces as I can. So this is what I have so far. I can extend this side because I know I'm going to have shading. Okay, what does our sign mean? So I'm going to bring this sign down. Okay, this is what it looks like. That is a less than sign. Less than, not, or equal to. So that tells me, because it's not equal, we're going to have a dotted line to connect our points. Less than means things that are getting smaller, and that usually to me would mean below, because that's what it does mean. We're going to below shade this. So we're going to connect with a dotted line. And shading below will be everything underneath. Here's my vertex, so everything underneath. So this is all below. Okay, and that one's done. Moving on to number 6. We have y is greater than or equal to negative 2 times the absolute value of x plus 3. Still starting by finding my vertex. What is the XY coordinate? That's the center of this V. I have a +3 that's inside with the X, so it's going to come out as a -3 for the X value. I have nothing being added or subtracted outside the bars. It's like saying +0. So the Y value of the vertex is 0. So we're going to put our first dot. We're going to 1, 2, 3 left, not go up or down any, and there we go. My slope, okay, the slope, what's in front of the bars? I have -2 out in front. So that tells me it's -2/1, or in other words, down 2, right 1 from the vertex. Okay, and again, this negative sign that's out front should always tell us that our arrows are going to end going down. So down 2, right 1. Again, and if you had a graphing calculator or using Desmos, you could also connect the points using that. Okay, now to finish this up, okay, we have to talk about this sign again, so let's bring it down. This is a greater than or equal to. Okay, so that tells me two things. Because it's or equal to, we get to have a solid line. I bet I can spell solid better than that. There we go, solid line. And because it's greater, that means we shade above. Okay, shade above the vertex. So a solid line to connect our points. Here's my vertex. We're shading above. So everything on this outside part of the V. Shade it good enough for me to know where it is you're shading, and that's done. Okay, next we're moving on to our quadratics. Again, when we see quadratic, that's telling me that we have an x squared. Okay, it's the highest exponent in our function, and that always makes a parabola or a U or a rainbow of some sort. So we have two different forms that we usually have these equations shown in. One is standard form, the other is vertex form. We all tend to like vertex form a little bit better because it helps us identify the vertex and graph a little bit more quickly. But both are good and both have its uses. Okay, we're used for different things. Standard form means our function is in the form f of x equals ax squared plus bx plus c. Notice there are no parentheses. We start with our x squared term, next our x, and last comes our constant. It's all in a row. Vertex form usually, almost always, has parentheses. It's in the form f of x is equal to our a value times x minus h squared on the outside of the parentheses and then plus k. Where our vertex is, okay, it doesn't say that on here, but the vertex comes from the h and the k values. Take the opposite of what's inside with the x. The k value is the y value of the vertex, and it stays the same. So on number 7, if you're looking at number 7, you should recognize that this does not have any parentheses. It goes x squared, then our x, and then our constant. So this is in standard form. When you're graphing any kind of quadratic, you need to find the vertex, whether it is in standard form or vertex form. But when it's in standard form, like this one is, you use a formula to find the x value of the vertex, and then we plug that value back into the equation to get the y value of the vertex, because we always need a table of values, so to speak, to graph a quadratic. So again, we always need to know where that vertex is. So you do have two choices here. If you were taking a test like we're going to, you could type it into your graphing calculator and then go on your vertex hunt by going to the table of values. But I'm going to show it here with the long way. The formula is x equals -b over 2a. So remember before I had you label your a, b's, and c's. Our a value is a number in front of x squared, that would be 1. B is a number in front of x, so it's -2. C is the constant, it is -7. So if we do -b over 2a, we're saying that x is equal to negative. The b value is -2 over 2 times the a value, which is 1. So this comes out to be +2 divided by 2, which equals 1. The x value of our vertex is +1. Now, how do we get the y value for the vertex? We plug it back in for all the x's in the original equation. So we would have 1, oops, I didn't write that right. We have 1 squared minus 2 times +1 minus 7. And then you type this into your calculator. And what does that equal? That equals -8. Okay, so that means -8 is the y value of the vertex. So from there, we know where the center of our parabola is. We're at 1, -8, right down here at the very bottom. And we're going to work our way outwards from there. That means to the left of 1, we have 0, negative 1, negative 2. To the right of 1, we have numbers that are bigger, 2, 3, and 4. And then we would be plugging those in. When we plug in negative 2 for x, we have negative 2 in parentheses. Always use parentheses. Squared minus 2 times negative 2 minus 7. And that equals positive 1. Okay, so we have a coordinate at negative 2, 1. When we plug in negative 1 for x, we have negative 1 squared minus 2 times negative 1 minus 7, and we get negative 4. So when x is negative 1, y is negative 4. That's another coordinate. Then we plug in 0. We have 0 squared minus 2 times 0 minus 7. All those ones equal 0, so we're left with negative 7. Now you should notice if you went one step further, we already have the vertex and we plugged in positive 2. We would have positive 2 squared minus 2 times positive 2 minus 7, and this would equal negative 7 again. So notice we start having symmetry, and that's kind of how you recognize it on your graphing calculator's table of values. When we plug in 3, we are also going to get negative 4. These two values are going to match. And when we plug in 4 for x, we get positive 1. So we have all the symmetry which every parabola has. So on either side of our vertex, we're going up to negative 7. On either side of that, we're at negative 4 for x, or for our y value, excuse me. And then on either side of that, okay, x values, we're working our way outwards, we're at positive 1. And then we connect all of our points. All right. So there's our parabola. Happy, nice parabola. Very symmetrical. The axis of symmetry is this imaginary, and I'm going to kind of show it with this highlighted mark. It's this line that cuts our parabola into two equal pieces. We could fold our parabola, okay, in half right there, and our two sides would line up. Notice it always passes through the vertex. So axis of symmetry, because it's the equation of a vertical line, all vertical lines, it feels like they should start with y equals, but they don't. It starts with x equals, and since it passes through the vertex, it's the x value of our vertex, so x equals 1. Okay, you always have to have that x equals there. The vertex we know is at 1, negative 8. What is our domain? Okay, our parabolas always are spreading from left to right forever without interruption, so their domains are always all real numbers too. Finding the range for these is very similar to finding the range for absolute value. You have a turning point at your vertex, so we're either never going above or below that vertex. Our vertex here is called a minimum. Okay, what's that y value of the vertex? It's 8, and we are moving for y. We have y values always above 8. So we would say the range is all the y's such that y will always be greater than or equal to negative 8. Okay, and that one's done. Okay, on number 8, we have f of x equals negative 3x squared plus 5. Again, because it has the squared up here, we know that it is going to make a parabola. Every time you see x squared, and that's the highest exponent, it always generates a parabola. Because it has this negative out in front of the coefficient of x squared, I know that this is going to have arrows going down. Okay, so negative, people frown, arrows go down like a frown. Here we go. Now, technically, this is in standard form or vertex form, but let's pretend like we didn't know that, and we'll just use the same method. You can always use our formula of x is equal to negative b over 2a to find our axis of symmetry and the x value of our vertex. Okay, because we do need to know where our vertex is before we can graph this. Where's our center? The a value here, that's some things that we need to keep in mind. The a value is negative 3. It's the number in front of x squared. The b value is the number in front of x. We don't have one, so it's 0. And our constant is 5. Okay, constants don't have any variables or letters after them. So if we do negative b over 2a, we have x is equal to negative 0 over 2 times negative 3. But remember, whenever 0 is in your numerator, everything equals 0. Okay, and then we would plug that back in. So this would be negative 3 times 0 squared for x, okay, plus 5, and that will equal 5. So our vertex, we know now, is at 0, 5. So we're going to stay here in the middle and go up 5 spaces and plant our dot. That means our axis of symmetry always passes through the vertex. So our axis of symmetry is this vertical line, And we would say it's x equals, because it has to start that way for axis symmetry, the x value of the vertex, which is 0. So we are moving our way outwards for the x values for the vertex. So that would be -1, -2, -3, and +1, 2, and 3. So when we plug in -3 for x, okay, again, that's just putting it in here. I'm going to show it one more time. I'm going to run out of room, but that would be -3 times -3 in parentheses squared plus 5. We get -22. And that's not going to fit on our graph, but we can still write it on our table. When we next plug in -2 for x and do -3 times -2 squared plus 5, we get -7. When -1 is plugged in for x, we get +2. When 1 is plugged in, okay, now we're going to have the symmetry. We're going to get 2 again. These numbers start repeating. We should expect that. If it doesn't happen, we're doing something wrong. And then when we plug in +3, we get -22 again. So let's plot those points. We're going to be at +2 for y on either side. And then we're going to be at -7. And notice this is skinny. That's what this 3 did. The negative said we had arrows going down. The 3, its absolute value of that -3 is it's greater than 1. So that meant we have a skinny, skinny parabola. So we're right here and right here. Their arms are very close together. All right. The domain does not change. No matter how fat or skinny our parabola is, it is always spreading outwards, left to right forever without interruption. So that is all real numbers. We have a highest point. Our vertex here is called a maximum. Our highest y value is 5. Again, we can see it here on the table. We can see it visually on the graph. And all my arrows are going down underneath 5, or getting lower than 5. So we would say our range, we have y's such that y will always be less than or equal to +5 for y. And that one's finished. Now on number 9, I love number 9, you should notice that we have these parentheses, x plus 3 in parentheses, and then squared outside of it, plus 2. That means this is in vertex form. So without using a formula like I had to do on the other problems, I can identify the vertex. So the vertex again is our xy coordinate. If we have +3 inside the parentheses, out comes -3. The y value will be what comes after our parentheses, or the x squared value, and that's +2. So we already have that vertex. I have -3 for x, +2 for y. Okay, and then the axis of symmetry goes along with that. We always start x equals. It's the x value from the vertex, so it's x equals -3. So let's go ahead and label that on our graph. -3, +2 is right here. I know that my arrows should end up going up because out in front of the parentheses, I do not have a negative sign. So to finish this, you still would need a table of values. And then we're going to say that -3, 2 is in the center of your table of values. And again, if you're doing this on the test, you're most likely going to be typing this into your graphing calculator, and then from there going to the table of values that the graphing calculator makes for you and then plugging them in. So if I were to do that and look at my my graphing calculator, it's nice because I already know what the vertex is. So I'm just going to move my cursor on the x-axis until I find that vertex of -3, 2, and then I'm plugging in -4, -5, -6. I like to do a few values on either side, and then to the right we have -2, -1, 0. It shows that just like that on our table values on the calculator as well. And then I look at those numbers at -6, and then the y side of my table, it shows me 11. When I plug in -5, it shows me, or on the table, it shows me +6. -4 matches with +3, and then we start having symmetry. And again, that's how you recognize it. The values start repeating. We have 3, 6, and 11. So we are going, again, this is going up. So on either side of this, we are at 3 for y. And then we're going up to 6, and then 11 won't fit, but I do know it's getting skinnier as we go up, so I won't let them get too far apart. Okay, the domain will never change for these. Our domain is still going to be all real numbers, left to right spread without interruption. Range, okay, what do we have here? My vertex, find your vertex. This is a lowest point. What's the y value? Again, range always means y's. This y value is +2, and we're moving above, so that tells me we're getting greater than 2. So we start having y values, or range, for all the y's such that y will be greater than or equal to positive 2. Okay, so number 10, we have f of x equals negative and then in parentheses x minus 4 squared. Again, saying that squared tells me that we're going to have a parabola. This is in vertex form because we do have a shift inside the parentheses with the x, so that's nice. And then this negative sign on the outside tells me that this parabola, the arrow should be ending down. We should have a reflection. So those are things that we're on the lookout for. I can pull the vertex when we're in vertex form, the xy value, our center of our parabola. What number is inside the parentheses with x is going to come out as the opposite sign, so it's going to be positive 4. The y value would be coming after this. It's like saying plus 0. There's nothing there. So our vertex is at 4 for x, 0 for y. Right here, we're making our first dot. And again, we're making this table of values, okay? Using either, you could use Desmos if you're at home, you can use your graphing calculator like you would do on a test, but one thing we should all be able to do is identify that vertex, and that's at 4, 0. That means we want points to the left and to the right of this value. So we have 3, 2, 1 for x as we move to the left, 5, 6, and 7 as we move to the right. Okay. When we plug in 1 for x or look at our graphing calculator, we should see that the y value that matches up with that is negative 9. When 2 is plugged in, we get negative 4. Again, you could be looking at your graphing calculator. 2 is paired with negative 4. 3 is paired with negative 1. It would be the same thing if I plugged 3 in for x. Computed this, I would also get negative 1. That's what the table of value is showing you. What happens when you plug in each of these x values? What's the y answer that goes with it? At 5, we have that symmetry, negative 1. These numbers are going to start matching up. 6 and negative 4, 7 and negative 9. Okay, we have that nice symmetry about that point. So on either side, we're at negative 1. And again, my next dots after the vertex are going down, which I expected to happen because we said this was a negative or sad parabola. On either side of that, we are at negative 4. So 2, 3, 4. Okay, negative 9 on either side of that would be about here because this is an 8 by 8 grid. And now we would connect our points. Okay, so where is our axis of symmetry? Let's look. The axis of symmetry is that vertical line that would cut it into 2 equal parts. It passes through the vertex. So we're going to say it's x equals, because it's a vertical line, the x value of the vertex is 4. So x equals 4. We already knew the vertex was 4, 0. The domain, at this point, you should all know the domain stays all real numbers. And the range, okay, kind of looking at your vertex, is it a highest or a lowest point? It's the highest point. The y value, because range means y's, the highest y value here is 0, and we're getting lower than 0 for our y values as this graph or arrows move down forever. So we're going to say our range, or the y values, are all the y's such that y is less than or equal to 0. Okay, number 11. Again, this is in vertex form. I can find the vertex. We have 1/2 times x minus 5 in parentheses squared minus 6. So let's find our vertex from here. The x value that's going to come out if it's negative 5 would be positive 5. The y value is negative 6. Okay, so 5 to the right, 6 down. Puts us right here. I know that it will be ending up. So what is the job of this 1/2 out front? Okay, I would say that you compare that value, that's the a value, we compare it to 1, it's less than 1, so this is going to be a compressed or a vertical shrink. It's going to be a little bit fatter than normal. So if I'm making a table of values, okay, we're going to write that down. We're going to have 5, negative 6 in the center, and then you could then type it into your calculator to get the rest of the points. Now, when I'm looking at the table of value that my graphing calculator has made for me, I can see that some of these values give us a fraction answer for y. And I don't necessarily love plotting fractions, so I'm going to kind of skip over some points. If we put in 4 for x, the answer for y would be negative 11/2. So I'm going to kind of skip over that because the next one, if x was 3, we get negative 4. That's a bit easier to plot. 2 spits out an answer of negative 3/2, so we're going to skip that one because we can. And 1 for x gives us an answer of positive 2. So if we do have whole number points that are there and can fit on our graph, let's stick with those because it makes it just a little bit easier to plot. Now moving to the right side of 5, 6 gives a fraction, but 7 doesn't. If we put 7 in for x, we get -4. And again, we have that symmetry still, so that's no big deal. And then 8 gives a fraction, but 9 gives us +2. Okay, so as long as we're symmetrical, we're in good shape. So at 3, we're moving outwards by 2 here. So 1, 2, we're going up to -4. And then we're going outwards by 2 again, and we're going to be up to +2. So that's about here. We're a little bit off the grid, but that's okay. So 1, 2. All right. So see how it is a bit wider than usual? Okay, that's because of that 1/2 in front of our parentheses, in front of the x squared. But we still have symmetry, we still have a vertex, we still have an axis of symmetry that we can all identify. So this vertical line that cuts it into 2 equal parts is at x equals, the x value of our vertex is 5. The vertex is 5, -6. Our domain stays the same, all real numbers, no matter what our vertical stretches or shrinks are. And our range, our lowest point here is at the vertex. That y value is -6, and we're moving above -6 for the y's. Up and down is range. So you would say this is all the y's such that y is greater than or equal to -6. Okay, for numbers 12 and 13, we get to write the equations for the quadratics based off the translations or transformations it is telling us about in the problem. This is very similar to numbers 3 and 4, but we did those equations for absolute value functions. So remember, any left or right shift will happen inside the parentheses with the x. The squared will go on the outside. Any vertical shifts will happen after the x squared value. If we have any stretches or shrink, it will go out in front of the parentheses. So let's look at what we have. We're saying we are vertically stretched. So vertically stretched, I did not want to do that. Nope, here we go, sorry about that. We are vertically stretched by a factor of 4. So vertically stretched by 4. Okay, that's going to be out in front of our bars. And then we're shifted 7 units right. So we start with f of x equals stretches or shrinks happen out front. So we're going to do 4. And then left or right always mean we need parentheses. You always start with x, and we're shifted 7 units right. Okay, right uses a minus sign. So minus however many units we shifted it, so -7, and we put the squared after it. It did not say anything about moving up or down, so we just leave it exactly like this. Okay, so that's done. Number 13. Okay, reflected across the x-axis. As soon as I see reflected, I'm thinking, hey, there's going to be a negative sign out in front. We're vertically compressed by a factor of 1/2. Okay, stretches or shrinks, compressions happen in front of the parentheses as well. Then we're shifted 4 units left and 6 units down. That's a lot of fun stuff we get to do. So let's start f of x equals. Reflected means I'm starting with a negative sign. We have a compression, so this is out front too with a negative by 1/2. So we have -1/2. Because I have a shift that said left in it, I know I have parentheses. We will have x. Left means to add, so +4. Left 4 is +4. We close our parentheses and we square it, and then 6 units down happens after this, so -6, and that one's finished. Okay, numbers 14 and 15. These are going to be the last 2 examples on this video. I'll do another video to do the rest of the examples from the study guide just so that this video isn't like super long. So we have quadratics, but we're using inequalities as well. Again, I'm looking and I'm noticing that I have this squared business going on. Okay, so that does tell me I have a parabola, but because we have this inequality sign, I know that I'm going to have to check how I connect my points, dotted or solid, and I will have shading either above or below. So this is red. Y is greater than or equal to -x squared minus 6x minus 1. Now this is in standard form. So when you're in standard form, you really got 2 choices. You can use your formula. You can do x is equal to -b over 2a to get the x value of your vertex, and then plug that in to get the y value and keep moving from there. Or you could type it into your graphing calculator. Okay, your a value would be -1, the b value is -6, the c value is -1. So doing -b over 2a, we have -6 over 2 times -1. This would be positive 6, excuse me, divided by negative 2, which would leave us at x equals negative 3. Okay, so for your table of values, you'd be starting in the middle. For your vertex, we would have negative 3, and then we would plug that negative 3 back in for our x's, meaning we would have negative sign, then parentheses, negative 3 squared minus 6 times negative 3 minus 1. And out would come, this is equal to 8. So our vertex is at negative 3 for x, positive 8 for y. So we're at the tippy top of our coordinate system right there. Again, working our way outwards, okay, from the left and right of negative 3 for our x values, we would have negative 4, negative 5, negative 6, and negative 2, negative 1, and 0. When we plug in negative 6 for x, we get negative 1. When we plug in negative 5, we get 4. Negative 4, we get 7. Again, I'm not showing this. I'm really strongly believing that you understand that what I'm doing when I say this is the number inside the parentheses is being changed each time. For negative 2 for x, we get a positive 7. So we start being symmetrical. You can even take that shortcut. Okay, 4. And then for 0, we get negative 1. So continuing on with our graphing, we're going down to 7 on either side of our vertex. And then we're down to 4 on either side of that, so in the middle. And then we're down to negative 1 on either side of that. So here and here. Now I'm going to stop, and I'm going to look at my sign. Okay, this is a greater than or equal to sign, so that tells me that we get to connect our line with a solid line because it said or equal to. Okay, like this. And are we shading above or below the vertex? This is greater than, so we're shading above. So that would be, here's my vertex, can't really show above, but it's everything on this outer side of our parabola. So this would be shading above. Ta-da! Okay, let's look at number 15. So for number 15, let's move it over here. We have y is less than 2 times x plus 4 in parentheses squared, and then subtracting 4. And again, I see this business right here, and I know that I am in vertex form, which means I don't have to use negative b over 2a to find the x value of our vertex. I know that the x value of the vertex is going to be negative 4. The y value of the vertex is going to be negative 4. So we have that right there in the middle of our table of values. This 2 out front, it's not the slope because parabolas do not have a constant slope. Okay, so that job's, it's greater than 1. It tells me it's going to be a little bit skinnier. So filling in the rest of our table, we got negative 5, negative 6, negative 7 for x as we move to the left, and negative 3, negative 2, negative 1 as we move to the right. Okay, my table of values is telling me when I plug in negative 7 for x, I get positive 14. When we plug in negative 6, we get positive 4. For negative 5, we get negative 2. Okay, we already had the vertex. For negative 3, we get negative 2. Again, these should be matching. Negative 2 and 4, negative 1 and 14. Okay, all that lovely symmetry. So when x is negative 4, y is negative 4 right here. It's a little bit skinnier, so we're going to go up by 2 for our next spot in. So negative 2, and then we're at positive 4 on either side of that. And I can't graph 14. I just know that it is getting really skinny. And I see I almost connected my points. I forgot to think. Check your sign. Ooh, that would be a bad mistake. So this sign right here, this is a less than sign. Okay, not or equal to. Because it's not or equal to, I have to use a dotted line to connect my points. Less than, values that are lower, we go below. So we have shading below the vertex. So here's my vertex. Below is everything underneath and on the side. Nothing on the inside of it. Okay, so there will be another video that has the rest of the problems from our study guide, but this is the end of our first video.